Hello everyone, I welcome you all and in this video we are going to discuss the numerical from your unit number 1, that is vector analysis, and this numerical is related with the coordinate system transformation. Okay, so before we begin, if you have any queries you can drop me a mail onto my this email ID. Okay, now we will start with what is given to us and what is to be done within this numerical. Now, if you look out for this numerical, you will find that we are given with the two different vectors which are expressed in terms of that x, y, and z components. So that means what? These two given vectors are given in the rectangular coordinate system, and we have to convert it into the cylindrical coordinate system. Okay, so for that purpose, we will be needing the conversion table for converting your this rectangular system to this cylindrical coordinate system. So before we begin with this numerical, we will go through the basics of that table. So I would like to suggest you can take the screenshot of that table, or you can write it somewhere so that we will be using throughout this numerical. And for your theory exam point of view, either way you can write at some rough work, or if you are enough confident that you know about the dot product in between that two vectors, you can go directly with that one. Okay, so the thing is that we are going to make use of some conversion table and conversion values in order to simplify this numerical. So we will start with that conversion table, and I will keep that at some corner of the same slide so that timely you will come to know about the dot products in between that two vectors. So we will be writing that conversion table now. Now this is the conversion table that we will be using throughout this numerical. So we have the dot over here that represents you the dot product. Now the dot product in between what? So since we are dealing with the Cartesian system, so we are going to write the components of the Cartesian system, and that are what? That are your ax cap, ay cap, and az cap. And what are the components related with the cylindrical system? So we have that to be what? A rho cap, a phi cap, and a z cap. Okay, fine. Now what is the dot product in between that ax and arrow? So dot product in between that ax dot arrow is equals to what? We have that value to be cos of phi. Now the dot product in between that ay and arrow, this ay dot arrow is equals to what? We have that value to be sine of phi, and dot product in between that az dot arrow, we have that is equals to 0. In now the dot product in between that ax and a phi is equals to what? We have that value to be minus of sine phi. This ay dot a phi is equals to what? We have that to be cos of phi, and here az dot a phi, that value we have equals to what? That is equals to 0, and this last column, so we have that is equals to dot product in between that ax and az is equals to 0, dot product in between ay dot az is equals to 0 again, and dot product in between the same vector, that is az and az is equals to what? From the property of vector dot products, that is equals to 1. So this is the table that we will be using throughout your this numerical. Now the next thing is we have been using is what? We are going to make use of these values of that x, y, and z. So if you look out for the second part of your numerical, you have been given with some vector which is located at point q, and this q is expressed in terms of what? It have the coordinates like this x, y, and z. So we have to convert that x, y, and z in order to get our cylindrical conversion into cylindrical system. So what we have value for that one? So we have that rho is equals to, we can get the value of that rho by using that x square and x and y and z. So that we have rho is equals to square root of x square plus y square. We have the phi is equals to what? Phi is nothing but your tan inverse of y upon x, and z is as it is. So these are the two things that we will be using throughout our this numerical. Now we will start with the very first part of the numerical, And for your reference purpose, I am going to keep this table onto the one side of the corner of this slide. Now we will begin with the very first part of the numerical. Now within this very first part of the numerical, we are given with some vector. So assign that given vector A, or write that uh, your given vector A, or you can say let your vector A is equals to what is your given vector. So vector A, we have that is to be 5ax cap, which is at point P. And what are the coordinates of point P? They are already given to be 4, 120, and this 2. So what is this 4, 120 and this 2? So it is expressed in terms of rho, phi, and z. That means we have the value for that rho is equals to 4, phi equals to 120, and z is equals to 2. Now we are going to convert our this given vector A, which is basically in what? In which system is this one? So it is in the rectangular system, or you can say the Cartesian system. So we are going to convert that rectangular system into this cylindrical system. Now your vector A can be expressed in cylindrical system as, so what will it will be now? Your given vector A, it will have the magnitude A rho in A phi direction. It will have some magnitude A phi in A phi direction, and it will have the magnitude AZ in AZ direction. So this is how we are going to convert, or this is how we are going to represent our vector A in terms of the cylindrical system. So assign some equation number to that one. Now we will find very first magnitude of your given vector. So what is that arrow? So arrow is the very first one. Now arrow is what? Projection of your vector A, given vector A, into what? Into arrow cap direction. Okay. So if you have gone through my previous slide, I have written in details over there. Here in this case, I am not going to write in details. So what is this? Projection of vector A into arrow cap direction. So what is your given vector A now? We have that vector A is equals to simply 5x cap. We don't have any other elements over there. So 5x cap, it will have the dot product with what? It will have the dot product with arrow cap. Now we can refer this table, conversion table over there. So what we have for the dot product in between that ax and arrow. So dot product in between this ax and arrow, we have that is to be equals to cos of phi. So we have that arrow is equals to what? Cos phi. And again, we have the value of that phi over there. So we are going to put the value of that phi. So what is the phi value we have? So we have phi is equals to 120 degrees. So put that phi as 120. Okay, fine. So what is the value of arrow that we are going to find? So that is equals to minus 2.59. Sorry, minus 2.5 itself. So this is what? This is the magnitude of given vector A along rho direction. Okay, so assign some equation to that one. Say for now equation 2. Now next is we have to find out the magnitude of A phi component. So in similar fashion we can write for that A phi. So what is your A phi? A phi is nothing but given vector A, projection of given vector A into A phi direction. So this is how you are going to write in your examination. So what is your given vector A? Given vector is 5ax cap and a phi. It will have the dot product with a phi. Now you can refer that conversion table. So what is that? Ax dot a phi we have. Ax dot a phi we have, that is to be equals to minus of sine phi. Minus of sine phi, and ultimately you just put the value of that phi over there. So what we have the value for that phi? We have phi is equals to 120 degrees. So from that you will get the magnitude along the phi direction. If you go through that calculations, so you will find that a phi to be minus of 4.33. So this is your second magnitude of your given vector A in the phi direction. So assign some equation to that one. Now next is left. What is left? We are left with AZ. So what is magnitude along Z direction? So it will be your projection of vector A into AZ direction. And what we have vector A? We are given with vector A as 5x cap having dot product with what? AZ. Now from this convergent table, what is the dot product in between that AX and AZ? We have the dot product in between this AX and AZ is equals to what? 0. See over here. AX dot AZ is equals to what? 0. So we have that value to be equals to 0. From this you can write that magnitude along Z direction is equals to 0. Sorry. Assign some equation number to that one. So this is our equation number 4. Now we are going to combine all of these four equations to get our value. Okay, so what we have? You can write over here combining equation 1, 2 and 4, 1, 2, 3 and 4. We will get combining equation 1, 2, 3 and 4. We get. So for some student, I have been going through very basics, so it might be my videos might be lengthy. Okay, so see it into increased speed on your YouTube channel. Okay, so fine. So what is vector A row now? Vector A. So we have that given vector A is to be a row, capital A row cap, this A phi cap, and plus AZ, AZ cap. Now we are going to put the values of that magnitudes along rho phi and Z direction. So what is your vector A now? Vector A is equals to magnitude along rho direction is what? Minus of 2 phi, minus 2.5 A rho cap. And what is magnitude along my A phi direction? So that is minus 4.33, and along what direction? Along A phi direction. And for AZ we have that value to be equals to 0. So we are not going to write that one. So this is your final answer for your part number 1 of the numerical. Simply we have been given with the given vector in rectangular system, and we have converted it into that cylindrical system, that is in terms of that rho and phi and z. Now we will be moving on to the second part of the numerical. Now, if you look out onto the second part of this numerical, we are given is some vector which is expressed in terms of x, y, and z, that is in Cartesian system, and it is located at point Q, which is again at the Cartesian system. That is x. We have x is equals to 2 over here. We have y is equals to 3 over here, and we have z is equals to 5. Okay, so what we have to convert? We have to convert this x, y, and z in terms of the cylindrical system. So for that purpose, we will be using these values as rho is equals to what? We have rho is equals to square root of x square plus y square. Okay, so what is x? We have that x to be 2 square, this y to be 3 square, and square root of this will be it is coming around 3.60. Okay, now next is what we have phi. Phi is given to be what? Phi is we have phi is nothing but tan inverse of y by x. So put the value of that y. So what y we have? We have y is equals to 3 divided by x, which is equals to, that will give you the phi is equals to that answer we have is equals to 56.30. And okay, next, before moving ahead, I would like to tell you that if we are given with coordinates which have the positive values of x and y, so this phi will work. But what about if any of the coordinate is given with negative sign? So for example, it is not related with your numerical, but that one is tricky part. Many students get failed over there. Okay, so if we are given with, say, coordinate of point A having this to be minus 2 and this to be minus 3 and this is plus. So the thing is that you have the x and y coordinates in terms of minus values. So we have that x and y over here minus. So what we have to do, we have to add up this phi of the tan inverse of the given x and y with respect to 180 degrees in order to get correct value of the phi. The practice you have been doing is this, that you are going to put simply tan inverse of y by x and then you are going to find out the value of that phi. But most of the students get failed over here if any of the coordinate is negative over there. Say for now, if you are given with these coordinates, that is 2, minus 3 and 5, still you have to add up these phi with respect to 180 degrees to get the correct value of that phi. So this is the tricky part of this numerical. Okay, since we are given with the positive values of x and y, so you need not have to worry over here. Okay, so we will be continuing with our z value. So here in this case, z will be as it is. And what is that z we have? We have z is equals to 5. Now we have that row phi and z. Now we will find out what is the conversion of this rectangular system into cylindrical system one. Now let us assume that your given vector, this is nothing but your vector b, and we have to express that vector b in terms of this one. Okay, so assume that this is your vector b, which is initially expressed in terms of rectangular system, and let given vector in cylindrical system. In cylindrical system will be like this one, which will have the magnitude of b rho b phi and bz along a rho a phi and az direction. Okay, so we are going to find out what is that magnitude b rho. So as stated earlier, what is b rho? So b rho is nothing but what? Let me write it over here. We have, or we can say now. Okay, so now we are going to find out b rho. So what will be the b rho? B rho is nothing but what? It is projection of given vector b into arrow direction. And what is your given vector b that we have assumed? That is to be given vector of your second part of the numerical, that is 4ax cap minus 2ay cap minus 4 az cap, having the dot product with what? With arrow cap. Okay. Now what is the dot product in between that ax and arrow? So dot product in between that ax and arrow from this conversion table we have, that is to be equals to cos of phi minus dot product in between ay and arrow. So dot product in between that ay and arrow we have, that is to be equals to sine of phi. And what about the dot product in between that az and arrow? So dot product in between az and arrow is equals to 0. So we are not going to write that 0 value over there. So this is the 0, and from previous slide you can refer that one. We have found the value of that cos of phi. Sorry, not cos of phi. We have found the value of the phi. So what is that phi value we have? We have phi to be 56.30. So put that value over here. Again, minus of 2 sine of 56.30. Okay, now we will be doing that calculation in order to get the magnitude of that 0, and that magnitude you will be finding around 0.55. So this is your very first magnitude in the cylindrical system. Assign some equation number to that one. Say for now this is your equation number 2. Now we will find what is B phi. So what should be the B phi? B phi is again magnitude of magnitude along, sorry, B phi is what? Projection of given vector B into A phi direction. Now we have that vector B to be what? 4x cap minus 2 ay cap minus 4 az cap, having dot product with A phi. Okay. Now what is dot product in between that ax and A phi? You can refer that table. See over here. Dot product in between ax and a phi. Dot product in between ax and a phi is equals to what? Minus of sine phi. Dot product in between that ay and a phi. So dot product in between ay and this a phi is what? We have, that is to be equals to cos of phi, and dot product in between that az and a phi. So dot product in between that az and this a phi is what? We have 0. Now we are going to put that values of that respective dot products. So we will be writing it as dot product in between ax and a phi. We have, that is to be equals to minus of sine phi. So that will be this magnitude of 4 as it is, minus of 4 sine phi, and then minus of 2 cos of phi, minus of 2 cos phi. Now put the values of that phi over there and get the calculation. So 4 sine of 56.30 minus 2 cos 56.30, and after simplification you will find that B phi is equals to what? That will be around minus of 4.4375. So this is the magnitude along your phi direction. Assign some equation to that one. Say for now 3. Now we will find what is the magnitude along BZ. Now what is magnitude along BZ in similar fashion that you can write? So BZ is nothing but projection of given vector B into AZ direction. So we have the given vector B, its projection along AZ direction. So we have assumed that given vector B to be what? Sorry, we have not assumed, we have just have given name to that one. So this is your given vector of the second part, that is 4x cap minus 2ay cap minus 4 az cap, which have the dot product with az cap now. Now you can refer the dot product table or you can simply use the property of the dot product. So for your reference, I'm going to make use of that dot product table. So what we have over here, we have that. Okay, let me take that table for you over there. See, that is not necessary that you should take that table uh, in your theory exam. Just for your reference purpose, I'm going to take that table nearer to that one. Okay, so this is the dot product table that I have been using for your reference purpose. So what is dot product in between that ax and az? So dot product in between that ax and az equals to 0. So we have the very first element equals to 0. Dot product in between ay and az. So dot product in between that ay and az is equals to again 0. So we have this element again 0. And what is left? So dot product in between the two same vectors is equals to 1, or you can refer this table. Dot product in between that az and az is equals to 1. So we have this 1 over here. So what is the bz? Magnitude along your z direction is equals to what we have? We have that to be the minus of 4. Okay, so these are the three elements that we will be using. Assign some equation number to that one. Say this to be equation number 4. Now we are going to combine all of the four equations to get the value of your given vector in terms of the cylindrical system. So B rho, what is the magnitude of that B rho we have? So put the value of that B rho from your equation number 2, that is 0.5555, sorry, 0.5554. Now this arrow cap will be over there. So that is what? Your B rho arrow cap. Now what is the value of that B phi? So we have that B phi is equals to 4.4375. Sorry, sorry. We have the magnitude of that B phi, that is equals to what? Minus of 4.4375 A phi cap. Okay. And what is the magnitude along that BZ? So we have that BZ is equals to what? Minus of 4. So put that magnitude of minus 4 there, and this is what? Minus 4 AZ cap. So this is what? This is your given vector B, or this is the vector B which have been expressed in terms of cylindrical, sorry, which have been expressed in this Cartesian system into its cylindrical form. So this is our final answer. You can appreciate my video by hitting the like button. Okay, thank you.